Hello everyone, this is Vanessa and I'm presenting our ISOM 358 project. So we are Highland Bakery, a small coffee shop opened in Emory University near Goizueta Business School. You all know we serve very good coffee and beverages. However, we now have an operational problem. It's really hard for us to determine how much supply we should stock every week. My manager just shouted at me today because I bought too many chocolate syrup and no one is buying mocha this week. It then occurs a huge inventory cost. However, I'm also very afraid of understocking, because after all, no one wants to dissatisfy their customers. Sorry, we don't have that. It's definitely not the first line of quote you want to hear at 8 a.m. on Friday. As a result, we hire an external consulting group to help us design an automated inventory management system to help small businesses like us control our stock and minimize the cost due to the inefficiencies. This is the model we made for our business. This model contains 5 major features: weekly summary, item menu, inventory, and weekly invoice. Of course, here's the major optimized model in the first step. So now let's go through all the features. The first one is the weekly invoice, and it's the actual invoice we get last week. We recorded every transaction, and it has the item ordered, price, and the variable cost of each drink. From the item menu tab is where we calculated our variable cost of each drink. The menu contains information such as how many servings of each ingredient are used in every kind of coffee or beverages. As for the inventory tab, we can manually input our current stock. And here, we calculate the cost per serving, which generated from the unit cost divided by the total servings we have in stock. The next, we have the weekly summary tab, where it gives us a direct summary of this week's sales and revenues. The first part is the actual sales, which offers information such as number of customers, the total number of cups sold, revenue, ingredient costs, stocking costs, and the final profit. The second part is the further breakdown. It calculates the weight contribution of each beverage sold. There is also a pie chart to give us a more direct understanding of how the revenues are contributed. And finally, it comes to the major chunk of the model. We have the inventory information of week 1. The demand is generated from the historical informations, and it can also be manually input by users. As you can see, the model takes the beginning inventory into consideration for further calculations. The decision variable should be how much ingredients we should purchase from this week. As we have our demand for this week, we can calculate the variance easily. The inventory of week 2 is pretty much the same. We just extend the prediction to 2 weeks to make it more accurate. So here comes to our cost information. We have 2 types of cost, the overstock cost and the backorder cost. As for the overstock cost, it will only occur when we have too much ingredients in our storage, and it can be considered as the depreciation cost. It's calculated by multiplying the ending inventory by the inventory cost per unit. The other cost is the backorder cost. If we are out of some ingredients, there should be a backorder cost. Let me show you the ingredient contribution tab to further explain the backorder cost. The ingredient contribution shows the weighted contribution of every ingredient in different drinks. Since we have the cost per serving, we just calculate the total cost of servings we need for each drink, and then divide it by the total cost of the drink, and then times the profit. For example, The ingredient information shows that every 1 cup of cappuccino sold, we can gain $1.97 from 1 serving of milk. That's how the backorder cost is generated. And finally, comes to our constraints. First is the inventory capacity. We believe the capacity varies from business to business, so the users can enter the capacities by themselves. We also separate refrigerated items and non-refrigerated items to be more realistic. And also, we have a budget for buying supplies since we can't spend every penny on that. By adding the 3 costs together, we can have our total cost. Now let me run the solver for you. When I click the Run Solver button on the home page, all the decision variables will be 0 and run the solver for me to get the result. Of course, there are some limitations to our models. First of all, the demand is always unpredictable. Although we have historical data, it's still not possible for us to accurately predict the demand every week. Secondly, we didn't allocate the depreciation cost of the machines and other possible costs. Last but not least, notice that we are using a nonlinear model, which means the answer might not be the best. However, it's still a local minimum point, and it should be much more accurate than we calculated manually. That is all for our project. Hope you all liked the idea, and thank you for your time.